for me, it's modular. Modular means for scientists' needs, I have to build a reflection and how to be active in these needs. Technological use a technology, but not so obsolete. And a platform, what is it? A platform. A platform, what is it? A platform is, well, there's several actors. The mains are, for example, scientists, teachers, professors, students, ITs, and industry, partners in the industry. All these actors have to be connected together. And, well, I'm the man in the middle, you know, the cheese in between the two slices of bread. What I need to present is in 5 items: the review, the immersion, what I understood, the conception, and use and evolution possible, and commercial aspect. A general review. The other platform, in fact, it doesn't exist, they are rare. As Jean-Pierre said last time, there is a 3-4 platform, and you can buy a platform on shelf. It doesn't exist. So you have to imagine it, invent it, and every time, and it's not every year. It's 6 months after 6 months. The technology is arriving, and your platform is became so obsolete. And we will see how you can build a reflection, following Florence also in informatics, how we can do a good concept. So this is a platform is rare, unique, in fact. When you think about Wageningen or the others, you can. It's difficult to say, well, we are looking what they do and we are doing the same in another place. What you can do is, well, there is a problem on this platform, and we don't want to do the same. Well, this is an experience, but you can do your own like that. So there is several also aspects to take care. Is the commercial partnership. This is sometimes good, but it's quite a bit dangerous, because platform is by some partnership, and even if the partnership is necessary, people who are selling after during this partnership to another company or for studies or for researchers, this is really well, unstable. So we are going to have a look on the world around us, a technical look. We have first the research and academic needs. So as a technician and as an IT, you have to always keep in mind what scientists need, what teachers, professors, students need, what could be the future curriculum could they organize. So this is another difficulties to imagine. Then in the industry, also there is the food industry, which is a good. We had to learn, in fact, a lot in looking around us in the industry, because it's not necessary to invent again the hot water. So in the industry, they have the money, they have time. Also, there are R&D services to develop some research center. So it's important also to keep in mind that you can have any learning from them. And for example, this is a logger for a cold chain. You put it in the in trucks or boats, or to track the temperature of the food. And this tracker gives you the information that temperature always stay correct during the transport of foods. This is for any food, fruit or meat or something like that. But it also exists for eggs. You put wrong eggs, and for transportation you can log at the arrival. You put the cylinder, and you can have a look on what is the temperature and the hygrometry of during all the transportation. Then, in the factory, in the main company, from aerospace company, famous Airbus, what are they using in the factory? Well, have a look here. They build also something for the future. So the factory of the future, this is nice for the restaurant of the future. And they use their, to have a look on, they have a partnership with a society which is National Instrument. We will see later what is National Instrument as company also. I continue the review with the CERN. Vincent presented this company as a real main company, a research company in nuclear domain in Europe and in the world, I think. And also they use some tools coming from National Instruments. This is really important. Why? Because they put all together a partnership to certify National Instrument. So this is there is a meaning between these two items. The result, they build some tools with this company, means there is quality behind this one. Perennity. It's a conception for long term. You can go to National Instruments. Another point is National Instrument, what they do. They build some software packages and framework to build software. And how they do, they offer a professional conception software and hardware, and we will see later. And also, this is recent, but I'm sure there is some interest for them in. So, when you see the next picture, don't laugh, but this laugh is looking like a do-it-yourself board, electronic one. Well, this is a cheap board. It's about $30. It's really cheap. There is analogic output, analogic input, digital one, Ethernet port, USB port. You can lots of parameter. You can use hygrometer, you can use light detector, you can, well, it's only for prototyping, but it's cheap. And we will see also why I talk about this. So the language uses interface is very simple, and you can look the Arduino here, and the board of the experiment is here. You can see small messages, small buttons, small hygrometer, and analogic input. So this is only for proof of concept. Then another model, the Raspberry Pi. Perhaps you heard this, but it's the same concept. Very small, very cheap. A new one is appear there is 1 week. It's half a hand, like this, and they call it Raspberry One, and is about $10. $5? Okay. 2 for me. So this is nice, and nice product, and based on Linux language, you can use Python. And for example, in proof of concept, you can put a small camera, a small script on Python to test face detection. This is really cheap, and it exists. So if I continue, National Instrument, this is not really the same category. This is really expensive hardware, modular hardware. For example, several categories of hardware, but this one is PXC, and the PXC is well, a box. And in the box, you put what you want. What you want is UC. It's one, you can recognize the Ethernet port, VGA port, USB, and so on. You can put several cards, so video card and analogic card, and what you want is, so it's modular. That's why in the title there was modular. This is, we can consider it as the Earth, what we are looking for. There is a language to program the box we saw the slide before, is a graphical language, but gets some input here. But these input are coming from the boxes, from the cards we saw. So we can use analogic input, or a digital input, or video input, or sound input. The treatment is here. You can see some loop of treatment and the output. The output can be files, can be digital output, analogic output, and so on, or stream, or everything like that. And also, it's not a blind output. It can, you can build also, well, a complete panel on screen. And when you modular screen, it's linked with your schema, and when it runs, all this active. So during the evolution, when, for example, this input is moving, it's not analogic, it became digital on, I don't know, 32 bytes, sorry. I don't know where is it, but you can switch this graph from analogic to digital, and all is modular, hardware and software. We can see that there is a sort of the market of this framework and hardware also is going top, down, up, and bottom up. The cheap and the expensive. And so we can see also some devices. So that's why we have we had to be very attentive on several devices like cameras, video cameras. Not all cameras work with this equipment, but they develop some software to be in connection with such components. I'm just always talking about a large review, about the connected object and software development kit. About the object connected. It exists, bottle, connected, and this is nice. Is just to share with you, keep in mind what is gadget, where is the border between gadget and real interest object connected. It's difficult. One, you have to say, oh no, it's not interesting, and or saying, well, it can be aggregated to found a research project. So the bottle can be logged with the way how the milk is drunk. It exists also fork connected. This is also interesting because if you how it works is if you eat too fast, the fork is moving and is locked. So in bariatric surgery, for people who had to learn again to eat slowly, this is an interesting thing, and it could be oriented in a network, a fork network. It exists also thermostat, on which is interesting also on platform, all these sort of tool and so on, thermostat, and for example also glass which analyze your personal hydration needs. All these are object and cheap, quite cheap. The glass is about $100. So always gadget or not. When scientists are talking about emotion, this is difficult for me to appreciate where is the right meaning, the link between these sciences and the techniques. So when Jean-Pierre talked about with me about the theory of the basic expression, yes, it's very basic and the surprise, but it's really rare when you are surprised to open the mouth and say, oh, no, I don't think so. And it depends also of the ethnic, and well, it's a bit difficult. I have a look also on the other approach of Ekman theory. The micro-expression is worse for me. It's very, very thin expression. And if you compare this expression with the 6 basics 1, I'm really disappointed. How did you, could you recognize the sadness and But there is two sadness. Difficult, really difficult. And this is white people, but you have several possibilities. Well, we are in the theory. The Ekman theory has in the micro expression. It talks about facial expression, body language, tone of the voice, verbal style, content, and so on. So content, difficult. You have to recognize what people are saying, even if they are eating. You could appreciate the progress of Siri, of iPhone component. Woo. Okay. Well, it's difficult. So perhaps another way, the thermal imaging. I'm going faster. Thank you. The heart rate, the capture of temperature of carotid, the main vein also, and you can have also the frequency profile of the heart. The frequency of the heart, the breathing, the temperature only with thermic infrared, thermic around the nozzle. And you know if the heart going faster, the person breathing deeper or slower. And for example, an experiment where the mother is synchron, this is the mother and the children were also together observed behind a mirror, and the toy is prepared for the experience, ready to break, to make the little boy, and the mother doesn't say it, to make the little boy annoyed and embarrassed. And you can see here the nose, there is a thermic, here is the presentation, begin playing the accident on the toy, and then and at the hand is smoothing because you know but it's prepared before. The conception overlay. What we have to do and is to organize a cross-reading between scientists, IT, partners, and product representative to be agreed to put away all misunderstanding on reading needing. So we saw this morning the map of Valley, of the concept of hospital, family, canteen, self-services, restaurant, gastronomic restaurant, plane, focus group, all these area monitored, all these places, the needs in sensors are completely different. So how can you build something to observe children and observe someone who is sick? In such a project, you have also to build a project with, the needs, that's evident, the communication, all during the project, from the beginning to the end. It's not at the end of a project that you have to think how we are communicating on. This doesn't work. What we can do to organize the gain of this platform, and so on, how to build proof of concept, organize the R&D, research and development around this platform. Data, what is possible. But Florence tell you more about this. Or organize a technological survey which is acceptable. I just make a reference to the border of a gadget border. Sorry. First, use the industry benefits. So, if Airbus certified a partner, have a look on, and why? Because in academic circuit, to work with national instrument for us, university, is cheaper. Why? Because the software they sell an academic version. Lots of editors, software editors, sell academic version. This is an important point also. So when you choose the hardware, for example, IR camera, you have to pay attention to the quality of the camera. You can make some tests with, proof of concept camera, but there is several differences between, for example, cooled camera and uncooled camera, infrared. After 2 minutes, you have also the hands, and you lost it here. You can do some analysis on after some touch. 2 minutes later, for example, a child is away, and you have also some possibility to analyze. And these 2 minutes could be also an element of a research, but this part is for scientists. So it must be modular, mobile because we have to keep in mind that you can build an experiment in a hospital or something like that. So to bring the equipment in a place, but also move from a building to another building. No wise soldier, I mean. I don't know if you understand, but if you have to cut the cables, the wires, it's not so good. Non-owner, this is really important to add a software which is not a lock, which is open. Always keep in mind that the software develop a tool with an open software where you can modify it always and grow up in the functionality. So the Earth could be seen as a nut, an empty nut, like this. This is the PXE, empty. And then you can have the CPU, as I said, and the board, the cards, sorry. This is the bottom of the PXE. You can chain it and grow in complexity. So we can imagine why the CERN choose this equipment. So mobile, but wide. So if you have to move with it, it's possible to disconnect, but connected also is huge. I show you an example of partner to illustrate how it's important to choose the right partner. This is a sample of a company which built a software or is very, very interesting in a such case as emotion, like Valley, and you scan the face with a small 3D camera, which is the equivalent of Kinect. Then, once you scan your face, you get it, and you can build the mesh and shift the mesh to an alias. So this is not so important, but this is really important because you can see there that all this mesh is built with nodes, and the nodes are, for example, you can modify, you can identify the point of the move here, the corner of the eye, and this is in fact the muscles of the expression. And you can, for example, you can have all the expression there, the mesh, and if you modify the parameter, the mesh of the scan move. Very interesting, a good start for us. All these spatial coordinate, you can export them, get a flat file stream, and so it's not so easy to use it and in informatics. So there is a problem with this one. It was so good that Apple bought it and it disappeared. 2 years of as a Switzerland, coming from Holland also. Switzerland, yes, and is bought by Apple. Who is using the solution? Who is going to use the platform? Pay attention to users and patients. The data carrier, if we are deeply connected with internet to export data, for example, this is not the right carrier. What are the data collected? Is there is something to privacy? It's not so good. iWatch had lots of parameter that people can use, and you have your systolic pressure, your weight, your I don't know, the last time you use or very privacy parameter, and collected, and where these data are going. For example, in Netherlands, it's forbidden, it's not allowed to record voices and people who's speaking. So recognizing speaking is not allowed. So if you build a tool or organize some research with Dutch people, it's not a good plan. Another point, it's important to organize a quality plan to prevent all failure, and also audit for this equipment what happens if during an experiment some cameras going down on and the time also you have to restart the experiment. This is something you have to pay attention. Commercial aspect or academic use, organize it, and need also to pay attention about the commercial constraint. I mean, if you buy software where is written only for academic use, it's difficult after, I think it's impossible, to organize research with commercial purpose. That's all. Sorry, I'm a bit long.